Welcome back to Chem 330. We're in week 3, the first video of week 3. Alright, and as I mentioned on my last video towards the end of week 2, that our new concept for discussion would be called hybridization. Okay, I don't want to dwell too much into the orbital diagrams and stuff because that's definitely a little bit for more advanced classes, but I want to just use the knowledge that you already have to explain this concept. If you go back to your Chem 170 and 175, you probably have heard these things: S, P, D, and F orbitals, right? All right. S is circular, P is more like a dumbbell, D have quite a bit of shapes. They look like this, and they also look like this. Okay, this is S, this is P, these two are D, and then F, we also have F orbitals. Okay, so when a carbon combines with an hydrogen, let me just say for one, okay, again I don't want to go too far into the concept. Okay, a sigma bond, right? And then you, this is a single bond, and then so the orbital from carbon and yes, okay, right? So let's say we have this, okay, this is methane, right? It only has, right, single bonds, right? So this compound contains 1 s orbitals and 3 p orbitals. Well, if that's a little bit complicated for you, let me make it simple. Okay, a compound containing a carbon, okay, we only focus on the carbon. It's not about hydrogen or some other element. Hybridization is a concept that's uniquely dedicated for carbon most of the time. All right, so this is methane. Okay, if a compound contains carbon attached to only single bond, then we say that the carbon is sp3 hybridized. Okay, we can go into discussion on how we got the sp3 at a later point of time, or probably not. Okay, but this is good enough. If a carbon contains all bonds to which that carbon is attached is single bonds, it's sp3. So only carbon attached to single bonds. Now let's take a compound. Let's say if a carbon contains, okay, a double bond and 2 single bonds. Keep in mind it still has to be, right, it still has to be, let's say if this is the compound, right? So that means, let's say this compound continues on and on. Okay, let's keep going. Okay, let's say this compound contains a carbon, and then let's say the sequence goes on. This is such a long compound, but I'm just giving you a short version of it. Now this compound contains this carbon right here. We're focusing, as I said, on the carbon. Okay, if a carbon contains at least 1 double bond, okay, if a carbon is attached to at least 1 double bond, okay, then whatever those carbons that contain the double bonds are known to have sp2 hybridization, or sp2 hybridized. So is this, because this carbon is also attached to a double bond, this carbon is also attached to a double bond, they share a double bond, so they're both sp2 hybridized. Now let's say you have a compound. Again, I am only going to give you a snapshot of a larger compound, because again you don't need to know the larger compound in this case to understand the concept. Now if a compound contains a carbon that contains a carbon attached, I should have at least carbon attached to at least, I don't think you can even use the word at least, but I'm using it, at least 1 triple bond is okay, is sp hybridized. Okay, okay, so this and this carbon, they're both sp hybridized. And this is important on a larger concept which we will come back and discuss later. All right, so we will probably have a practice activity just based on this. Okay, here's what I do want to say is, okay, right, so the question of planarity comes in place. Okay, let's say is a compound, because that has a lot of meaning in the real world. Is a compound planar or not? What is planar? Okay, the computer screen, say my screen at least is a perfect flat screen, and if I put it on a floor, it sits on the plane of the floor, right? That's planar. It's in aligned with the whatever be the plane. When you put in it, the two planes touch each other all the way, and that's planar. And if it doesn't, it is not planar, right? And they, like I said, that idea of planar, something being planar, has a more practical value in our day-to-day things. All right, so let's say some generalized situations. Okay, generalized situations where we can arrive without doing too much work whether a compound is planar or not, right? Okay, the first cases, I'm going to write these in different colors so that you can keep track of them. Okay, if a compound, okay, contains, okay, only, okay, single bonds, okay, and what did we call when, okay, only single bonds, and when, well, if a compound contains only single bond, then it's more likely sp3 hybridized, right? That carbon is sp3 hybridized. It's not the hydrogens, it's the carbon that's sp3 hybridized, right? What is that situation leads to? Well, the answer is quite simple. It is not planar. Means you cannot take those molecules and put them on a surface and they will stick out of the surface. An example is like a tripod, okay? A real life, which is a positive thing, right? You don't want your tripod to be on the plane of the floor, then it beats the purpose of it. If you notice, there are 3 legs to a tripod, right? And if you assume this is that little platform, and this is where, say, you put your camera, right? Your camera is, say, if this platform right here is the carbon, and this is one of the bonds, which is where your camera is, and these are the 3 tripod legs, okay? That means this carbon, as far as a tripod, is sp3 hybridized because it only contains single bonds all the way around, and that means it's not planar. And you do need that non-planar situation for a tripod to be effective, right? All right, very good. So if a compound contains only single bonds, sp3 hybridized carbons, it is non-planar, right? So let's go get our second situation. All right, if a compound, okay, if a compound contains, okay, a combination of alternate, okay, if it is alternate, it's important, alternate single and double bonds, okay, it tends to be planar, okay. That is, you have a carbon and a single bond, a carbon, double bond, single bond, carbon, double bond, single bond. The cycle goes on, okay, on this side and so on this side. If this is the case, if you pay close attention, okay, all right, so let's pick this one because it's right in the middle. Okay, let's pick the one in the middle because it will be the same across the board. Okay, why do I say it's planar? Well, let's pick this carbon, right? This carbon is sp2, right, because it's attached to a double bond. This carbon is sp2. This is again sp2. This again is sp2, and the list goes on. So what it means is an alternate way of saying the same statement, or, okay, or instead of saying if a compound contains a combination of alternate, okay, this is the key word here, okay, alternate. If it's not alternate, then it cannot be planar. Okay, so let me say the same thing in a different words, or the compound, okay, contains only sp2 hybridized carbons, then it is planar. There's two ways to state above statement. You pick which one works best for you. All right, so if it's not alternate, let's look at a case. All right, so that's pretty much what we have actually talked to today would be the case. So scenario C, okay, a compound, okay, compound containing, okay, just single and double bonds. It didn't, you're missing the word alternate here, single and double bonds, okay, in various locations. Okay, I'm using the word various location just to make it different from alternate. Is going to be not planar. Okay, let's look at an example for that, which is essentially what we have done. Okay, so we did remember, if you remember, I did C5H10, which is an alkene, and we wrote several isomers, and one of them was this, the straight chain isomer. Okay, this is what we wrote. If you go back, you remember it. As I said, this carbon is sp2, right, because that carbon is attached to a double bond, right? This is also sp2 because this carbon is also attached to a double bond and a single, but then it's attached to a double. This is sp3 because it's only attached to single. This is attached to sp3. This is attached to sp3. If you remember the scenario B that we looked at, everything I wrote was sp2. That because it was alternate, single, and double. Whereas here, it's double, single, and then a bunch of singles. Okay, this compound will stick out of the surface. Partly will be in surface, but partly out of the surface, and that's what we call it three-dimensional, right? There are some things that are at 3D, like a cube, right? You all played the Rubik thing, right? If you put a Rubik on the table, right, part of the Rubik sits on the table. That's why you're able to sit it on the table, right? So this, if assuming this part is what sits on the table, well, that is equivalent to a double bond, okay, whereas the rest of the surface is sticking from the desk where you're placing it, so that could be sp3, right? So all of the cube is sp3, whereas this area right here is sp2. That's why it's not planar, because your entire object must sit on the table to be planar. If only part of it sits, then it's not planar. Okay, even though part of it sits on the table. All right, so in other words of writing the same statement is, the C statement is, or if a compound contains a combination of sp2 and sp3, it is non-planar. Because remember, in scenario, I proved it to you that every one of them turned out to be sp2, right? All right. Moving on to the last one, D. Okay. D. If a compound, okay, contains alternate single and triple bond is also not planar. But what shape does it take? Not planar, but linear. Okay. I think we did an example on one of the alkene compounds. So we did say it's CnH2n minus 2. So if it is C5, we did say C5H8. This was one of the alkynes we did earlier. Okay, that means this was one of the straight chain isomers we identified, CH2, CH2, C triple bond CH, right? And we said it's one pentyne, right? That's what we called it, one pentyne. But if you notice here, this is sp because it's attached to a triple bond. This carbon is also sp, whereas this is all attached to single bond, so it's sp3, sp3, sp3. Now this is not planar. It is also not linear. Not planar and not linear. Okay. What's an example of a linear would be, say you have a compound. Let me get a different color. You have a compound that looks like this: C triple bond C, single bond C, triple bond C, single bond C, triple bond C, and the list goes on. Okay, on this side, on this side. Now if we come back and label this, you notice quickly this is a carbon attached to a, even though it's attached to a single, it's attached to a triple bond. That's all you need to know. sp, 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 and the list goes on, right? So let's come back and refresh that. So when a compound, so that's scenario E, when a compound, okay, contains, just like we said for alkenes, contains alternate single and triple bond, the compound is still not planar. The compound is not planar but linear. Okay. All right. And then this is kind of like an, I shouldn't call it E, it's just an extension statement, I should say. Okay. There is actually an E which I discussed in D, which is, okay, let me write it in different color. Okay. Okay, I provided the example, I just didn't make the statement. If the compound contains, just contains single and triple bonds, you see the word alternate is missing, then it is neither planar nor linear. Okay, this idea is very, very important in our daily life. All right, so we'll come back and do some more examples, but that's where I want to stop, and then probably when we see Monday, I'll give you some practice problems to work on that. Stay tuned.